find the intervals on which given function, which is negative x to the power 6 plus 12 times x to the power 5 minus 12x plus 7. So you want to see where this function is concave up, where this function is concave down. So our goal is to find the intervals where this function is concave up or down. And we are going to do that by using the concavity test. So if you are not sure what concavity test means, please watch the suggested video. I just want to write down here the summary of that. The concavity test says that if you have given a function f, let's find the second derivative of this function and try to see where the second derivative is positive. If you figure out on certain interval, if the second derivative is positive, then the function is concave up. Okay, and at the same time, if the second derivative you try to figure out and then it turns out that the second derivative is negative on certain interval, then the function is concave down. So this is the summary of the concavity test, and we are going to just use that test over here. Okay, alright, so you might have noticed if you want to use the concavity test, then we need to find out what is the second derivative of the function. So let's find that. But how do you find the second derivative of the function? Well, we first find the first derivative of the function. So let's find that first. So what is f prime of x for this function? Well, we first need to find what is the derivative of negative x to the power 6, which is negative 6 times x to the power 6 minus 1, so just 5, right? So plus, what is the derivative of 12 times x to the power 5? 12 times derivative of x to the power 5. So if you do that, then this will be 12 times 5 will be 60. So times x to the power 4, right? Alright, so and then what is the derivative of negative 12x? Just negative 12, right? And what is the derivative of positive 17? That is constant, so that the derivative of that will be just 0. So this is the first order derivative of the function. Let's find the second derivative, because that's what we are going to use in the concavity test. Alright, so let's go ahead and then do that. So what is the derivative of negative 6 times x to the power 5? That will be negative 30 times x to the power 4, right? And what is the derivative of plus 60 times x to the power 4? That will be plus 240 times x to the power cube, right? And what is the derivative of negative 12? Negative 12 is a constant, so its derivative is 0. So this is what we get as the second derivative of the function. Now to use the concavity test, we need to see the sign of the second derivative. So for that, I want to create the sign chart of the second derivative function. Okay, so on the real line, so I want to say this is sign chart. So you can say draw sign chart of the second derivative of the function. So to do that, construct a real line, and let's say negative infinity to positive infinity. Know what is the domain of the function. See if the function is undefined at that some location. If that is the case, use that number to partition this real line. But you can see that f of x is polynomial, so function defined everywhere, so we don't get partition number from there. Alright, so now let's try to see the second derivative and then see if that second derivative does not exist anywhere. But you can see here, this is the second derivative of the function that is also polynomial and it exists everywhere. That means this function is always defined, right? So we don't get the partition number even from there. Then what do you do? Well, there is another thing you need to check. You need to see where the second derivative is 0. So if that is the case, let me do some work over here to just check where the second derivative of the function is 0. What is second derivative? We get negative 30 times x to the power 4 plus 240 x cube. Let's set that equal to 0 and then solve for x. So let's work a little bit to solve for x and then see the number where the second derivative is 0. Okay, so to do this, we have the polynomial equation here. I think that I can at least take x cube out. Probably I can also take negative 30, but let's take x cube out, or if you like it, you can take it the common factor here, which are negative 30 times x cube, right? So as a common factor, you can take that out, and when you do that, what will be left over? On the first term, that will be just x, right? And on the second term, when you take negative 30 out from 240, there will be what number left over? -8, right? So that's how -8 times -30 is 240. So that's how we can take the factor out. So that's fine. And actually that's it, because x cube is already out. So x minus 8 is the remainder then. When you take -30 x cube out, right? So is equal to 0. So how do you solve this equation? We can divide by -30 on the both side. Then we get just x cube times x minus 8 equal to 0. But x cube means what? X times x, right? And all of them will give you the solution as x equal to 0. Right? That's the only solution we get. From here we get only x equal to 8. These are the solution of this equation here. And what does that mean? The second derivative is 0 at these two numbers, at x equal to 0 and x equal to 8. So why don't we use that over here to partition the given given the real line that we have created over here. So let's use that to partition this. So over here, let me use let's say again the blue color. So this one is here at, let's say, 0, where the second derivative is 0, and then let's use 8 here to partition this domain, right? So where the second derivative is 0. So when we do that, now we can clearly focus only over here on the sign chart that we want to create. So when we partition this, right, the real line, now our goal is to check the sign chart of f double prime. So if that is the case, choose some random number on each of the sub intervals here. I want to choose here -1. If you like it, you can choose some others. I want to choose here 1, and then over here 9. If you like it, you can choose any other. But no matter whatever random number you choose within each of these sub interval, I'm going to write down here the parentheses, okay, so that we will distinguish what sub intervals are they. So, and then you can choose any random number there, and then plug that into the second derivative. So if you plug -1 in over here on the second derivative, what do you get? -30 times 4th power of -1 plus 240 times cube of -1. Check what is that number. Okay, what kind of number you get? Did you get a negative number? Okay, if you get that, then it seems like you are correct. So then that will be the sign of the second derivative on that sub intervals. In the same way, between 0 and 8, so we have the 1 as a random number. Plug that in again on the second derivative. See what is the number you get. Okay, what I'm asking you to check is, see what is f double prime of -1, what is f double prime of 1, what type of number we get earlier. F double prime of -1 is a number which is negative, right? And then f double prime of 1, check that and let me know what is that number. What do we have it? Okay, it is actually positive number, right? So if that is the case, then this is positive here. At the same time, 9 plug back in on the second derivative, then we'll get a negative number. If that is the case, then we create the sign chart. But now why were we creating the sign chart? Well, we wanted to use the concavity test. Can we use the concavity test now? Probably, because we know where the second derivative is positive, where the second derivative is negative. So since the second derivative of the function is positive over here between 0 to 8, you can see that the function by the concavity test, it is actually concave up here, right? So it's concave up here. I just want to have that kind of notation to just write down over there to later on, let's say a symbol to write down there to later on for my convenience to say, oh yeah, okay, it was concave up there. Okay, so I just want to write down. But the fact here, the function is concave up is because of the concavity test right here, and because the second derivative is positive here from 0 to 8. In the similar way, from -infinity to -infinity to 0, right, you can see that the sign of the second derivative is negative. So by the concavity test, it is actually concave down there. The function is concave down here. In the same way, from 8 to infinity, the function is concave down. I was able to write down those symbol over there, or that fact over there, because of the concavity test. Okay, I'm done then. So because I applied the concavity test, now I know where the function is concave up, where the function is concave down. So that summary I can write down right over here as f is concave up. Where we figured that out, it's between 0 to 8, because the second derivative is positive, so it is actually concave up there. So let's write that down, between 0 to 8. And f is concave down. Where is it concave down? Wherever is the second derivative is, right? We have the second derivative negative over here from negative infinity to 0. So it is concave down here from negative infinity to 0, and then from a to infinity. So we can write down that as negative infinity to 0 and then a to infinity. We can combine these if we want as a union sign, okay? Or on some author they also write down the comma, but I think the union is the nice way to write down to combine these interval. All right.